Hello everyone, these are the Algebra 2 final review problems 4 through 7. I'm going to probably pretty briefly go through these because we've gone through factoring kind of a lot this semester, but I know some of you still asked for these to be done. So just keep in mind, anytime that you have a quadratic and it's got 3 terms, so it's got a power of 2 with 3 terms, it should factor into 2 binomials. And to check to see if those are factors, you would multiply those binomials together. Maybe we just haven't done quite enough of this together as a group. So remember, you just need to do FOIL, so x squared plus 9x minus 6x minus 54. And then you combine these middle terms and you get x squared plus 3x minus 54. And you can see this is what we've started with. And that's the whole thing. We are trying to pull apart this simplified polynomial and turn it into its factors. And so when you're doing a quadratic, remember the first term times the first term should equal the first term. Last term times the last term should equal the last term, right? So negative 6 times positive 9 definitely is a negative 54. And then the other thing is when you look at the outsides times each other plus the insides times each other, you should get that middle term. So x times 9 is going to be 9x, right? Negative 6 times x is going to give you that negative 6x. You add them together and you get your middle term. So it's really all you're doing is trying to find the right combination and positioning to get those terms. When the leading coefficient is 1, it should be the easiest. You're really just finding factors of this last term that add together to get the middle term. Jumping down here, when the leading coefficient isn't 1, it's a little trickier. This is a special one. Anytime that you have a leading coefficient that isn't 1, but it's a perfect square, like 25, and the last term's a perfect square, try just factoring it into those square roots. Now, if it's a trinomial, you keep all the signs the same. So everything's a plus, so everything's a plus over here. So we just did the square root of 25 as first, the square root of 49 is my last. And then when you check that, (5x times 5x is 25x). 5x times 7 is the 35x. I'm sorry, the first one was squared. 7 times 5x is 35x. And 7 times 7 is 49. Once you combine these like terms, you will in fact get back what you started. So sort of the thing to keep in mind, if you have a quadratic trinomial, the first term's not 1, but it's a perfect square, then try to see if they're both perfect squares and can be factored into basically the sum of the perfect squares. Otherwise, if you look at it, if it's again a trinomial, so 3 terms, and a quadratic, and the first term's not, a does not equal a perfect square, so in this case a is 7, which is not a perfect square, that's where you're going to want to make this table, where you do, this is our AC B table, right? So a times c is a negative 21, that's where this negative 21 came from. You're looking for factors of negative 21 that add up to b, which in this case was a negative 20. So we kind of cut to the chase because this is an answer key made by your teacher. So I knew it was 21 and 1, but most of you guys may have tried 3 and 7 first. And since it's a negative 21, one of them has to be negative, but that would have added up to a negative 4. So that doesn't work. And even if you change the signs, it's not going to work. It's just going to make it a positive 4. So then you'd have to think, well, what else goes into that 20? I'm sorry, into 21. And it's 20 and 1. Since it's negative, one of them has to be negative. And since my b is negative, the bigger value needs to be negative. Keep doing that. So that's where those terms came from. Once you find the value that multiplies to get your a times c and adds up to your b, then you rewrite your quadratic. You're going to keep your first and your last terms the same. What you're going to do, though, is you're going to split up your middle term. Your negative 20x now becomes negative 21 and positive 1x. And that came directly from here, from your factors. And then once you have 4 terms, we know every time we have 4 terms, we want to do factor by grouping. And so 7x squared minus 21, the 7x comes out. When you factor into 7x out of 7x squared, you're left with an x. When you factor 7x out of 3, you're left, out of 21x, you're left with a minus 3. And similarly, over here you have an x minus 3. There's no GCF between x and 3. I put this 1 here because most of the time, if you don't put a 1 in front of this parentheses, you guys kind of lose that back end of the expression. So now, x minus 3 is my GCF. I factor the x minus 3 out. I am left with the 7x plus 1 as my other factor. And you can multiply these together and check. And indeed, you should be multiplying them together to check. So that's 7x plus 1, x minus 3. Just foiling that out, 7x squared minus 21x. There's that 21x again, plus x minus 3. And you can see, once we simplify by combining like terms, we get a negative 20x in the middle, and we have back what we started with. There is another method for factoring that I posted on the Google Classroom. It's a PDF. It's called Divide and Slide. There's also some videos of it on YouTube. So you can check that out too if you're still having some issues with factoring. So our last factoring example that we haven't looked at yet on this sheet is number 5. So number 5, not a trinomial, so we should always look for GCFs first. So the GCF of 2x squared and 72, 2 goes into both of those. You pull that x out, that 2 out, and you're left with x squared minus 36. Anytime you have 2 terms, and one of them is squared, and one of them is a minus, check to see, is this a perfect square? If the answer is yes, then you have the difference of squares. Which is where you have a perfect square minus a perfect square, and they factor into a minus b, a plus b. So, if it is a difference of squares, think about, well, what's the square root of 36? Bring down your GCF. Make the first one x's if it's just an x, otherwise do the square root. Make one minus, make one a plus. Square root of 36 is a 6. So this is how this factors. And to check it, I'm just going to bring down my 2. X times x is x squared. X times 6 is a 6x. Negative 6 times x is a negative 6x, and negative 6 times positive 6 is a negative 36. So what happens is the positive 6 and negative 6 cancel each other out. So then you are only left with the x squared minus 36. That's why the difference of squares works. Distributing my 2 back in, I get 2x squared minus 72. which is what I started with, so I know that this is the factored form.